So welcome students. Today we are going to learn the topic of linear inequations. So this is a very simple topic and this comes handy when solving questions on different topics. So what is a linear inequality? So to understand that, let us first try to revise our knowledge on linear equations. So what is a linear equation? A linear equation is the equation of the form ax plus b is equal to 0. For example, so you can take a linear equation which looks like 2x plus 5 is equal to 0. So this is a linear equation. So what makes it a linear equation? What is the meaning of linear? What is the meaning of equation? So linear means that the degree of the variable is equal to 1. It is the maximum power of the variable present, which is x in the equation, is equal to 1. That's why it is called a linear equation. Now, why is it called an equation? We have an equality. So 2x power 1 plus 5 is equal to 0 is a linear equation. Now, what is a linear inequation? A linear inequation is a linear equation itself where the equality is replaced by any one of the signs greater than or equal to, or less than or equal to, greater than or less than. So if equality is replaced by any one of these signs, then such equations are called inequations. So inequations, linear inequations look like ax plus b greater than or equal to, less than or equal to, greater than or less than one of these signs 0. So for example, 2x plus 5 greater than or equal to 0. So this is a very simple example of linear inequation in the variable x. So you can create linear inequations in other variables also. Now, so what are we going to study in linear inequations? So in linear inequations, we are just going to study how to solve linear inequations. So in your lower classes, you have studied how to solve linear equations. So for example, 2x plus 5 is equal to 0. So how do we solve a linear equation? So we try to bring the variable onto one side and send all the other constants onto the other side of the equality. That is, 2x is equal to minus 5. So this plus 5, if it is going onto that side, becomes minus 5. And x is equal to minus 5 by 2. This 2, if it goes onto this side, becomes 1 by 2. So the solution of this equation is x is equal to minus 5 by 2. So while doing this, we have used some rules. So what are the rules that we have used? What are the rules that you have learned in solving linear equations? That is, if you have plus something on this side of the equal to, if it goes onto that side, it becomes minus 5. If there is minus 5 here, if it goes onto that side, it becomes plus 5. So plus something becomes minus something becomes plus something. And if you have 2 into x, if 2 goes onto that side, it becomes divided by 2. That is, if a multiplicand goes onto that side, it becomes divided by. And if you have x by 2, if it goes onto that side, it becomes into 2. So these are some of the rules that we use in solving equations. So let us use the same rules for solving inequations also. Let us see if they work or not. So let us do this. So 2x is greater than or equal to, if plus 5 goes onto that side, becomes minus 5. So 2x greater than or equal to minus 5. So x is greater than or equal to minus 5 by 2. Looks good. So if you look at the answer for this inequation, this will be the answer, right? This is the right answer that you get. But are we using the rules consistently? So does the rules that we use here work always? So now let us do the same inequation in a different way. So let us solve it in a different way. So now instead of sending 5 onto that side, let us send 2x onto that side. That is, 5 is greater than or equal to minus 2x. If plus 2x goes onto that side, it becomes minus 2x. So now let us bring this minus 2 onto this side. So 5 by minus 2 is greater than or equal to x. This implies x is less than or equal to minus 5 by 2. So 5 by minus 2 is same as minus 5 by 2. So you got the answer as x less than minus 5 by 2. So here you got the answer as x is greater than or equal to minus 5 by 2. We have used the similar rules. We have used the same rules. That is, if a plus number goes from this side to that side, it becomes minus, and multiplicand becomes divided by. But once you got the answer x greater than or equal to minus 5 by 2, you got the answer x less than or equal to minus 5 by 2. Obviously, both these answers cannot be right. If one answer is right, the other should be wrong. So, in the theory of linear inequations, we are going to observe what went wrong in one of these methods. So, something should have gone wrong in one of these methods. And what is that wrong? So, to understand that, we have 4 rules of linear inequations. So, we need to understand those 4 rules of linear inequations. So, let us go forward. So, the first rule of inequality says that any number can be uniformly added or subtracted from both sides of inequality. Can be added or subtracted from both sides of inequality. So, is the first rule which you already know. The wording might be confusing for you, but this is a thing which you do from your childhood. So, 2x plus 5 is greater than or equal to 0 if you have this inequality. Any number can be added or subtracted from both sides of inequality. That is, what I can do is so one side of inequality has 2x plus 5, the other side has 0. So I can add a minus 5 or I can subtract a 5 from both sides of inequality. This can be done. That is, plus 5 minus 5 becomes 0. 2x is greater than or equal to minus 5. This step is right. That is, 2x plus 5 is greater than or equal to 0 implies 2x greater than or equal to minus 5 is right. Similarly, if 2x plus 5 is greater than or equal to 0, any number can be uniformly added or subtracted on both sides of the inequality. So what I do is 2x plus 5, I'll subtract 2x on both sides of the inequality. So 2x minus 2x gets cancelled. 5 is greater than or equal to minus 2x. This step is also right. There's nothing wrong in these two steps. Because first rule says that any number, either positive or negative, any real number can be added or subtracted on both sides of inequality. So now let us go to the second rule. The second rule says that any positive number can be multiplied or divided on both sides of inequality. Here I am putting a condition. Any positive number can be multiplied or divided on both sides of the inequality. Now you have 2x greater than or equal to minus 5. 2x greater than or equal to minus 5. I can uniformly divide both of these sides by 2. That is, I can do by 2 here, by 2 here. So if I do this, 2 and 2 gets cancelled. This implies x is greater than or equal to minus 5 by 2. There is nothing wrong with this step. So x greater than or equal to minus 5 by 2 is right. So now let us go to this side. 5 is greater than or equal to minus 2x. Now if you divide both sides with 2, so 5 by 2 is greater than or equal to minus x. There is nothing wrong with this step. But if I want to send this minus onto this side, I need to divide with minus 1 or I need to multiply with minus 1. So can I multiply it with minus 1? Till now you have no rule which says that what should be done with negative numbers. So if a positive number can be multiplied or divided on the both sides of inequality, that's the second rule. Now let us go forward to see what should happen if I multiply or divide with negative numbers. So the third rule says that if a negative number If a negative number is multiplied or divided on both sides of the inequality, the sign of inequality changes. So if a negative number is multiplied or divided on both sides of inequality, then the sign of inequality changes. Inequality changes. That's the third rule. So from this rule, you can see what should be done in this method. 2x plus 5 greater than or equal to 0. So in the second method that we have done, if I send this 2x onto that side, 5 is greater than or equal to minus 2x. And this plus 2 can be brought onto this side. There is no problem. That is 5 by 2 is greater than or equal to minus x. Now if you want to make this minus x into plus x, you have two options. I can either multiply both sides with minus 1 or divide both sides with minus 1. So whatever I do, if a negative number is multiplied or divided on both sides, the sign of inequality has to change. So if I uniformly multiply both sides with minus 2, you get minus 5 by 2 here. Minus of minus x is x here. What happens to the sign of the inequality? It reverses. That is greater than or equal to will become less than or equal to. That means the final answer is x is greater than or equal to minus 5 by 2. So now once you have consistently used the rules of inequalities, you get the same answer whatever method you use. So 2x plus 5 greater than or equal to 0, 2x greater than or equal to minus 5, x is greater than or equal to minus 5 by 2. And here also you got x greater than or equal to minus 5 by 2. So this is the right answer to the inequality. This is the right solution to the inequality. So this is a very simple rule. If a negative number is multiplied or divided, then the sign of inequality changes. You have to remember this. This is the most critical point in linear inequations. So now let us go to the fourth rule, which is again related to this rule, which is called cross multiplication rule. Cross multiplication rule. This says that if A by B is greater than or equal to C by D, if you have a fraction here greater than or equal to or less than or equal to some fraction here. So how do we compare it with the solution of A by B equal to C by D? So you have encountered these equations like this in your lower classes. If A by B is equal to C by D, we know the cross multiplication rule, which says that AD is equal to BC. Can we do the same thing with inequations? Yes and no. So let us see what can be done here. So if A by B is greater than C by D, this implies AD is greater than or equal to BC. Can be done if this can be done if B comma D are of same sign. So cross multiplication can be done consistently AD greater than BC if B and D are of the same sign, that is either both are positive or both are negative. And AD is less than or equal to BC, that is the sign changes, the sign reverses if B comma D are of opposite sign. So this is called the cross multiplication rule. If you cross multiply with inequalities, so direct cross multiplication can be done if B and D are of both the denominators are of the same sign. You have to change the sign of the inequality if B and D are of the opposite sign. So these are the four rules of inequalities. So now let us apply these inequalities to solve our problems. So now let us look at different types of questions that are asked in this topic, linear inequalities. So the first type of questions that will be asked is very basic linear inequalities. Linear inequalities where you need to just use the rules of inequalities and get the answer. For example, 37 minus of 3x plus 5 is greater than or equal to 9x minus of 8 times x minus 3. This is a single line inequation. So how do we solve this? we just separate the variables and constants. 37 minus 3x minus 5, I am expanding the bracket, is greater than or equal to 9x minus 8x plus 24. So this implies, so you have 3x here, 9x here, 8x here. So I'll simplify x's and bring all x's onto one direction and all constants onto the other direction. 37 minus 5 is 32 minus 3x is greater than or equal to 9x minus 8x is x plus 24. This implies if you take minus 3x onto this side and 24 onto this side, 32 minus 24 is greater than or equal to x plus 3x is 4x. So if you take plus onto this side becomes minus, if you take minus number onto that side becomes plus. There is no difference in this operation in equalities and inequalities. The difference only comes when you take a multiplicand and you divide it on the other side. There is a difference for positive and negative numbers. So this implies 32 minus 24 is 8 greater than or equal to 4x. This implies x less than or equal to 2. That's the answer to this question. And if you are asked to plot this solution on a real number line, you draw the real number line. X is less than or equal to 2. This is, assume that this is 2. So my solution is, I just darken the number line on the left side of 2. So this is my solution. So if you have less than or equal to, you use a solid dot here. That means 2 is included. If 2 is not included, we use a hollow dot. Now let us go to second equation. Here x by 4 is less than 5x minus 2 by 3 minus 7x minus 3 by 5. This is also a one-liner. So you might have fractions, but you can take LCM and convert them into a single line inequation. So x by 4 is less than or equal to, if you take the LCM, you get 15 as the LCM. So 5 into 5x minus 2, 25x minus 10, minus 3 times 7x minus 3, minus 21x plus 9, minus into minus becomes plus. So this implies x by 4 is less than or equal to 25x minus 21x is 4x, minus 10 plus 9 is minus 1 by 15. So you can cross multiply this inequation because both the numbers here are positive numbers. Both are of same sign, hence cross multiplication works. So 15x is less than or equal to 4 into 4, 16x minus 4. So I'll send this minus 4 onto this side, 15 onto that side. This implies 4 is less than or equal to 16x minus 15x. This implies 4 is less than or equal to x. This implies x is greater than or equal to 4. So my solution is x greater than or equal to 4 if you are asked to plot it on a real number line. So on the real number line you have 4 somewhere here. You just need to take a solid dot here because 4 is included, and all the numbers greater than 4 are to be darkened. So you just need to darken this line here. So now let us go to the second type of linear inequations, that is multiple linear inequations. So here you have inequation in one line, but there are two inequations. So this is an example of multiple linear inequations. So in this multiple linear inequations there are two types. The first type is that you have variable only in one term and two terms will be constants. So both of this have variable only in the middle term and both the extremes are constants. So if the inequation looks like this is slightly easier. So what I do is, again, I'll use the concept of linear inequations. I'll use the 4 rules. So first, if I have to do this, so first you have 4 minus 7x by 2 lying between minus 3 and 18. So I'll subtract 4 uniformly on both sides, on all sides. So minus 3 minus 4 is less than or equal to 4 minus 7x by 2 minus 4 is less than or equal to 18 minus 4. So in the middle portion 4 and minus 4 gets cancelled. So minus 7 less than or equal to minus 7 by 2 into x less than or equal to 14. Now I need the solution for x. So what I do is I'll uniformly multiply each of this side with minus 2 by 7. So minus 7 times minus 2 by 7 and 14 times minus 2 by 7. And if I multiply minus 7x by 2 with minus 2 by 7, it becomes x. Now I have multiplied each of this side with a negative number, so the sign of inequality changes. So it becomes this. So 7 and 7 gets cancelled, 7 and 7 gets cancelled. So minus of minus 2 is 2 greater than or equal to x greater than or equal to minus 2. This implies x lies between minus 2 and plus 2. That's the answer to this inequality. That's the solution to this inequality. Next, if you go to the next inequality. So minus 12 is less than or equal to 4 minus 3x by minus 5 is less than or equal to 0. So I'll uniformly multiply each side with minus 5. So minus 12 times minus 5. So if I multiply this with minus 5, it gets cancelled. So you have 4 minus 3x. And 0 into minus 5 is 0. So does the sign of inequality change or does it remain like this? It changes because we are multiplying with minus 5. So less than or equal to becomes greater than or equal to greater than or equal to. So minus 12 into minus 5 is 60 greater than or equal to 4 minus 3x greater than or equal to 0. You can uniformly subtract 4. If you uniformly subtract 4, it becomes 56 greater than or equal to minus 3x greater than or equal to minus 4. And if you uniformly divide with minus 3, 56 by minus 3, x minus 4 by minus 3. So according to the rules of linear inequalities, the sign of inequality changes. Right? So minus 4 by minus 3 becomes 4 by 3. So x lies between minus 56 by 3 and 4 by 3. So that is the answer to this question. So the next type in multiple linear inequations is a linear inequation which contains variables on all sides. So you have variables here, here as well as here. So now how do we solve this? So we solve this like we solve two questions. So this is effectively two questions on linear equations. So what we do is we first solve this part of the linear inequation and then we solve this part of the linear inequation separately. And once you get two solutions, we find the simultaneous solution. So to do that, what we do is first let us take this part. So 2x minus 5 is less than or equal to 4x plus 7 by 2. So I'll bring 2x onto this side and 7 by 2 here. So 4x minus 2x is 2x is greater than or equal to minus 5 minus 7 by 2. This implies 2x is greater than or equal to minus 17 by 2. If you take LCM, you get minus 10 minus 7 minus 17 by 2. So this implies x is greater than or equal to minus 17 by 4. So this is the solution for the first part of the linear inequation. Now let us solve the next part, this part. 4x plus 7 by 2 is less than or equal to 2x plus 18. So 2x, I'll send it on to this side, 7 by 2, I'll send it there. So 2x is less than or equal to 18 minus 7 by 2. That is 36 minus 7. So 2x is less than or equal to 19 by 2. 2x less than or equal to 36 minus 7 is 19 by 2. So this implies x is less than or equal to 19 by 4. So if this part of the inequality has to get satisfied, x has to be greater than or equal to minus 17 by 4. For this part to be valid, x should be less than or equal to 19 by 4. Now I want both of these sides to be valid. This is a simultaneous linear inequation in which this has to happen and this has to happen. That means my solution should be the common solution for this as well as this. So what we do for common solution is we plot both the solutions on a real number line. So the first solution is, so let this number be minus 17 by 4. X is greater than or equal to minus 17 by 4. So all numbers greater than minus 17 by 4 are valid for this. Next, let us take this next solution. So you have a number 19 by 4. X should be less than or equal to 19 by 4. So for this equation to be valid, for this part to be valid, x should be less than 19 by 4. For this part to be valid, x should be greater than minus 17 by 4. For both of them to be valid, we have to take the common solution. That is, x is in between minus 17 by 4 to 19 by 4. So that will be the common solution to, that will be the effective solution to this inequation. Now let us go to the second. This is also a similar model. So again, I'll do the same process. So first, I'll solve this part and then I'll solve this part. So if you take the first part, x by 2 plus 6 is greater than or equal to x plus 2 by 6. So if you cross multiply because it's a positive number, you can cross multiply this. So 6 into x by 2 is 3x plus 36 is greater than or equal to x plus 2. So if I bring this x here, so 2x is greater than or equal to 36 if I send on to this side. 2 minus 36 is minus 34. X has to be greater than or equal to minus 17. So for this part, x has to be greater than or equal to minus 17. Now if you go to the second part, 2 plus x by 6 is greater than or equal to 3x plus 4 by 12. So because 6 and 12 are positive numbers, I can cancel this out 2 times. So I can cross multiply this. So 4 plus 2x is greater than or equal to 3x plus 4. If I send this 2x here and 4 here, 0 is greater than or equal to x. 0 is greater than or equal to x. That is, x is less than or equal to 0. So for the first inequation to be valid, x has to be greater than or equal to minus 17. X has to be less than or equal to 0. So what is the simultaneous solution for these two inequations? So if you draw the real number line, so one solution says that x should be greater than minus 17. The second inequation, the second part of the inequation says that x has to be less than or equal to 0. So what is the simultaneous solution? X is in between minus 17 and 0. So x belongs to minus 17 comma 0. That's the answer to this question. So in type 2 itself, the last model is direct simultaneous linear inequations. So in this type of questions, you will be given two inequations directly. You just need to solve both of these inequations and get the common solution. Something like 4x plus 3 is greater than or equal to 2x minus 17 plus 17 and 3x minus 5 is less than minus 2. So if you solve the first one, if you bring this 2x here and you send this 3 onto that side, so 4x minus 2x is 2x is greater than or equal to 17 minus 3 is 14, x greater than or equal to 7. This is one part, this is the solution for this inequation, and 3x is less than this minus 5, it goes onto that side, becomes plus 5. 5 minus 2 is 3. So x is less than 1. So if one inequation says that x has to be greater than or equal to 7, the next inequation says that x has to be less than 1. So let us plot both these solutions on a real number line. So if you take the real number line, one solution says that my x has to be greater than or equal to 7. The next solution says that my x has to be less than 1. So what is the common solution to these two inequations? You can see that there is no common solution. Hence, the answer to this question is no solution. So this pair of linear inequations or the simultaneous linear inequations does not have a solution. Now if you go to the second one. So here also you're given two inequations. You just need to solve these two inequations and get the common solution. So first inequation. So if you take the LCM here, you get 16x minus 27 by 12 is less than 4x plus 3 by 4. This 4 gets cancelled 3 times. Positive numbers can be cancelled out. So this 3 goes on to that side. 16x minus 27 is less than 12x plus 9. So this implies 16x minus 12x is 12x if it comes onto this side, that 4x is less than 27 if it goes onto that side, it becomes plus 27 plus 9 is 36. This implies x is less than 9. So this is one part of the answer. Now let's go to the second inequation. Here also I am doing the cross multiplication. So 6 into 7x minus 1, or I'll take the LCM as 6. So you have, just need to multiply the numerator with 2. So 14x minus 2 minus 7x minus 2 is greater than x. So this implies 14x minus 7x is 7x minus 4 is greater than 6 can be cross multiplied because it's a positive number 6x. So this implies if I bring 6x onto this side, 7x minus 6x is x is greater than 4. So the solution for this is x is greater than 4. The solution for this is x is less than 9. So what is the simultaneous solution? If you plot both of them on a real number line, one says x has to be greater than 4. The other inequation says x has to be less than 9. So what is the common solution to these two? So x belongs to 4, 9. So the next type of linear inequations are rational linear inequations. In this type of questions, you will be given a fraction where the numerator is a linear expression, the denominator is a linear expression. So x minus 5 by x plus 2 is less than 1. So in solving this, what you should not do is, you should not cross multiply this. You cannot directly cross multiply this. That is, you cannot say x minus 5 is less than x plus 2. If you directly do this, you won't get the right answer. Because if you cross multiply this, that means you're using cross multiplication rule. And we have seen in the cross multiplication rule that when you do cross multiplication, if both of these have same sign, then the inequality does not change. If both of these have opposite signs, the inequality changes. So we don't know the sign of x plus 2 because x plus 2 is a variable. Is x plus 2 positive or negative? I don't know. Till I find x, I don't know whether x plus 2 is positive or negative. So I cannot directly do this. So what do you do here? So the standard way is you bring all the terms onto one side. That is, this should not be done. So this will not be done. So what I do is x minus 5 by x plus 2, if it is less than 1, this implies x minus 5 by x plus 2 minus 1 is less than 0. This implies I take the LCM x minus 5 minus x minus 2 by x plus 2 is less than 0. X and x is getting cancelled. This implies minus 7 by x plus 2 is less than 0. So if I divide both sides with minus 7, if I divide both sides with minus 7, I get 1 by x plus 2. I am dividing with a negative number, so the sign of inequality reverses, greater than 0, because 0 by minus 7 is also equal to 0. So 1 by x plus 2 is greater than 0. You have a fraction, numerator by denominator is positive. And you can very clearly see that numerator is positive. Numerator is positive. So if numerator is positive and the fraction is also positive, then obviously the denominator has to be positive. So this implies x plus 2 has to be greater than 0. This implies x is greater than minus 2. So this will be the answer to this question. So is it clear? So instead of directly cross multiplying it, we bring all the terms onto one side. Then I get an effective fraction either greater than 0 or less than 0. So depending on whether the fraction is greater than 0 or less than 0, I'll do the analysis. Now let us go to the second question. So here also you have a fraction greater than 4. So instead of cross multiplying, I take this 4 onto this side. So 7x minus 5 by 8x plus 3 minus 4 is greater than 0. So this implies, now I'll do the cross multiply. Now I'll do the LCM. So 7x minus 5 minus 4 times 8x is 32x minus 12 by 8x plus 3 is greater than 0. This implies 7x minus 32x. 7x minus 32x is minus 25x minus 5 minus 12 is minus 17 by 8x plus 3 is greater than 0. This implies, now I'll uniformly multiply both sides with a minus because you have both of them minus. So if I uniformly divide with a minus sign, I get 25x plus 17 by 8x plus 3 is less than 0. Because if I multiply with minus 1, the sign of inequality reverses. So now you have an inequality. So a fraction is less than 0. So if a fraction is less than 0, what is your conclusion? Numerator by denominator is less than 0. That means numerator and denominator should have opposite signs. Numerator and denominator should have opposite signs. So this implies there are two cases now. Case 1, 25x plus 17 greater than 0 and 8x plus 3 less than 0. This is one option. Or 25x plus 17 less than 0 and 8x plus 3 greater than 0. You can have either this or this. So this implies x is greater than minus 17 by 25 and x is less than minus 3 by 8, or x is less than minus 17 by 25 and x is greater than minus 3 by 8. So either this or this. So here you need to find the simultaneous solution. Here you need to find the simultaneous solution. You have to find the union of these two. So what is the first solution? X is greater than minus 17 by 25 and x is less than minus 3 by 8. So which of these is smaller? So something like minus 17 by 25 is something like 0.6 something. This is 0.4 something. So minus 17 by 25 lies on left side and minus 3 by 8 lies here. So the first solution says that it's greater than this and less than this. Greater than minus 17 by 25, less than minus 3 by 8. So what is the simultaneous solution? It's in between minus 17 by 25 and 3 by 8. So x belongs to minus 17 by 25 and minus 3 by 8. If you go to the next equation, minus 17 by 8 minus 3 by 8. X is less than minus 17 by 25 and x is greater than minus 3 by 8. So what is the simultaneous solution for this? No solution, because there is no common solution for these two. So the solution is either this or this. You need to do the union of this and this. This set is null set, there is no solution. This set has a solution, x is in between this. What is the union of these two? The union of this will be the same thing. So the solution of this inequation is this. So now let us go to our third equation. X plus 5 by x plus 2 is less than 0. X minus 5 by x plus 2 is less than 0. So this inequation can be solved very directly. So you already have 0 on the right hand side. So you don't need to do anything extra. So x minus 5 by x plus 2 is negative. A fraction is negative implies numerator and denominator should have opposite signs. That is x minus 5 greater than 0 and x plus 2 less than 0, or x minus 5 less than 0 and x plus 2 greater than 0. So this implies x is greater than 5 and x is less than -2, or x is less than 5 and x is greater than -2. So these two are simultaneous linear inequations. These two are simultaneous and there is an OR in between. That is, you need to combine these two solutions. So let us plot these solutions on a real number line. X is greater than 5 and x is less than -2. So can you see that there is no common solution? So the solution for this is 5. Because you have an AND, both of them have to happen, both of them have to get satisfied, so there is no common interval. Or, so if you take the second one, 5 and -2, so x is greater than -2 and less than 5, so you have a common solution, that is x belongs to -2, 5. For this side to be valid, x has to be in between -2 and 5. So now this or this, that is 5 union -2, 5 is -2, 5. So the final answer is x belongs to -2, 5. So this is how we do type 3 problems. So the next type of questions are verbal questions. So these questions might also be asked in your exams. So here you'll be given a physical situation. You'll be required to construct the linear inequations yourself. So in this question, you're given that a manufacturer has 600 liters of 12% acid solution. And how many liters of 30% acid have to be added to this so that the concentration of the solution becomes somewhere in between 15 and 18%. So he has a 12% acid solution. He wants to concentrate it. So he is using 30% acid. So how much of this acid has to be mixed so that the resulting mixture has concentration somewhere in between 15 and 18%. So this is a very straightforward question again. So first let us say that let x liters of 30% acid be added. So let x liters, which I don't know, of 30% acid be required. So let us add x liters of 30% acid solution. So now what is the volume of the total solution? So volume of the total solution is nothing but initial volume is 600 plus x, right? And what is the volume of acid present in the solution now? So initially you have 12% acid, that is 12% of 600. So in this 600 liters, 12% is acid initially that is present, plus now what have we added? We have added x liters. So x liters of 30% solution, that is 30% of x liters. So this is the total acid present. So that is equal to, so if you take LCM here, 100. So it's 100. 12 into 600 is 7200 plus 30x. So this is the volume of acid present. This is the total volume. Now what is the concentration? The concentration is nothing but volume of acid by total volume. So the concentration is 7200 plus 30x by 100 times 600 plus x. So this is the concentration of the solution finally. And according to the given conditions, this has to be in between 15% and 18%. That is 15 by 100 and 18 by 100. So now you need to solve this inequation. The 100, 100, 100 gets cancelled. So I'll multiply both sides with 600 plus x. We know that 600 plus x is a positive number because this is a physical situation where x is positive. I know that x is positive, so I can multiply this. This implies 15 times 600 plus x is less than or equal to 7200 plus 30x is less than or equal to 18 times 600 plus x. So this implies 15 times 600. 15 6s are 90. So 90 hundreds, that is 9000 plus 15x is less than or equal to 7200 plus 30x is less than or equal to 18 into 6 is 108 hundreds plus 18x. So now we can solve this as two simultaneous linear inequations. So let us solve this first. So if I send this 15x onto that side, you get 15x is greater than or equal to 9000 minus 7200 is 1800. 9000 minus 7200 is 1800. This implies x is greater than or equal to 1800 by 15. That is 100 and 1s are 20. So x is greater than or equal to 120 liters. Obviously that's the unit that we are using. And the second part, 30x, 18x. If I bring 18x onto this side, you get 12x less than or equal to 10800 minus 7200. 108 hundreds minus 7200. So that is nothing but, so we have 3600. So 12x is less than or equal to 3600. So x is less than or equal to 300 liters. So x has to be greater than 120 liters and less than or equal to 300 liters. So that means for the concentration to be in between 15% and 18%, you have to add somewhere in between 120 liters to 300 liters of 30% solution. So let us take another example in this model. So in this question you're given that you have a company which manufactures cassettes, and the cost of manufacturing, the cost function is 300 plus 1.5 times x, where x is the number of cassettes sold. And the revenue function is r is equal to 2x. It is the revenue on each cassette is 2. So whatever number of cassettes you sell, you get 2x amount of revenue. So the cost of selling the cassettes is 300 plus 1.5x and the revenue is 2x. How many cassettes must be sold for the company to realize profit? So obviously you have to think of it physically. For a company to realize profit, obviously revenue has to be more than the cost. That is the condition for realizing profit. So revenue has to be greater than cost. This implies 2x has to be greater than 300 plus 1.5x. This implies 1.5x if it goes onto this side. 2x minus 1.5x is 0.5x is greater than 300. This implies x is greater than, if 0.5 goes onto that side, becomes divided by 300 by 0.5 is 600. That means the company has to sell at least 600 cassettes for the company to start realizing profit. And after that, whatever the number of cassettes are sold, the profit will increase. So let us look at another example. Now in this example, it's given that you have 640 liters of 8% boric acid solution, and how many liters of 2% solution have to be added to this solution so that the concentration becomes somewhere in between 4% and 6%. So you have to dilute this solution. Initially it is 8% solution. How much 2% solution should be added so that the concentration becomes somewhere in between 4% and 6%. So to solve this question, let us say that let x liters of 2% solution be required. Right? So let x liters of 2% solution be required for this condition to be valid. So now let us say that I have added x liters extra. So now what is the total volume of the solution? Initially it is 640 plus x. So the total volume is 640 plus x, right? So the total volume is 640 plus x liters. Now, what is the amount of acid present in the solution? So volume of acid present in the solution is, initially you have an 8% of 640, that is 8 by 100 of 640 liters plus 2% of this x liters, that is 2 by 100 of this x liters. This is the total volume of acid present. Now what is the concentration of this solution? Concentration is nothing but volume of acid by total volume into 100. That's the percentage concentration. So percentage concentration is nothing but 640 times 8 plus 2x by 100 times 640 plus x times 100. So this is the percentage concentration. This 100 and 100 gets cancelled, and according to the given information, this percentage concentration has to lie between 4% and 6%. So this implies 4 is less than or equal to 640 into 8. 640 into 8 is somewhere around 5120 plus 2x by 640 plus x less than or equal to 6%. So 640 is 2 power 6 into 2 cube is 2 power 9, 512, and in 0, 5120 plus 2x by this. Now this 640 plus x is a positive number, and I can uniformly multiply it on both sides. So this implies 4 times 640 plus x, 2400 plus 160, 2560 plus 4x is less than or equal to 5120 plus 2x is less than or equal to, if you multiply it with 6, you get 3600 plus 240, 3840, 3840 plus 6x. So this is a type 2 linear inequation where you have the variable on all the sides. So this can be solved like a simultaneous inequality. So let us first take this. So you get 2x is less than or equal to 5120 minus 2560. That is 0652. This implies x is less than or equal to 1280. So x is less than or equal to 1280. Now if you take the second part of the inequality, 5120 plus 2x is less than or equal to 3840 plus 6x. This implies if you send this 2x onto that side, 4x is greater than or equal to 5120 minus of 3840. So if you subtract this, you get 0. 12 minus 4 is 8. 10 minus 8 is 2. 4 minus 3 is 1. So 4x is greater than or equal to 1280. This implies x is greater than or equal to, just need to divide with 4, you get 320 liters. That's the unit. So the simultaneous solution is x has to be greater than 320 liters and less than 1280 liters. That means the amount of 2% solution that needs to be added is somewhere in between 320 liters and 1280 liters. So in the same type, let us look at another question. In this question, you're given that in a triangle, the longest side is 3 times the shortest side, and the third side is 2 centimeters shorter than the longest side. And if the perimeter is at least 61 centimeters, find the minimum length of the shortest side. So by now you'd have understood how to solve verbal questions in this topic. So you have to create a linear inequation in one variable. So whatever is the unknown, you have to assume it as x. So in a triangle, so given that you have a triangle, and in the triangle, the longest side is 3 times the shortest side. And look at the final part of the question. You're asked to find the minimum length of the shortest side. So let us assume that the shortest side is x. So let us assume that this is the shortest side, which is x. And it's given that the longest side is 3 times the shortest side. So let this be the longest side. So according to the given information, if this is x, this is 3x. And the third side is 2 centimeters shorter than the longest side. So this is the longest side. So the third side is 2 centimeters shorter, that is 3x minus 2. So if these units are centimeters, so those are the dimensions of the sides in terms of the shortest side. Now, how do we create the inequality from this information? The perimeter is at least 61 centimeters. So what is the perimeter? X plus 3x minus 2 is at least, that is greater than or equal to 61. This implies 7x minus 2 is greater than or equal to 61. This implies 7x greater than or equal to, minus 2 goes on to that side, becomes plus 2, 63. This implies x is greater than or equal to 63 by 7 is 9. This x has to be at least equal to 9. It can be greater than or equal to 9. Hence the minimum length of the shortest side is 9 centimeters. So now that you have learned both the theory and various types of questions in linear inequations, let us summarize the topic. It's a very small topic. So the first thing that you need to understand in linear inequations is the difference between solving equations and inequations. So what are the similarities and what are the differences? So in that topic you have learned the 4 rules of linear inequations. So with respect to addition and subtraction, inequations are exactly same as equations. That is, when a addition goes onto that side, it becomes subtraction. When a subtraction goes onto the other side, it becomes addition. The difference comes in terms of multiplication or division with negative numbers. So you need to remember this difference very keenly. So that's the crux of this chapter. So the crux of this chapter is just the difference between solving equations and inequations with respect to multiplication and division. So keep that in mind. And next, you have gone to different types of questions that you encounter in this chapter. So basic linear inequations, very easy to solve. Multiple linear inequations, you have more than one linear inequation in a particular question. So in that we have seen 3 types, and the thing that you need to remember is whenever you have multiple linear inequations, you have to find the common solution. You solve each of these inequations individually and find the intersection of all the solutions. Next, you have rational linear inequation. So you have something by something is less than or equal to something. So first you bring everything onto one side and make the right hand side is equal to 0. And then depending on whether the fraction is positive or negative, you apply different conditions. And lastly, you have verbal questions where you need to assume a variable. You need to assume something as x, mostly which is about which the question is asked. The variable about which the question is asked, you have to assume it as x. Create equations according to the given situation and solve the inequations using one of these processes. So these are 3 processes in which you can solve linear inequations, and in verbal questions you need to create linear inequation by yourself and then solve it. So that's about the chapter of linear inequations. Till now you have understood how to solve linear inequalities. Now let us go forward. So wavy curve method is a method that can be used to solve QPR inequalities. So what is QPR? QPR stands for quadratic polynomial and rational inequalities. So using wavy curve method, you can solve these 3 types of inequalities. So now, what are these inequalities? Let us try to analyze. For example, so till now you have learned how to solve linear inequations, something like x minus 3 is greater than 0. So this is a very basic linear inequality. X minus 3 greater than 0 implies x is greater than 3. So you know how to solve this. Now you'll be asked to solve not this, something like x square minus 5x plus 6 greater than 0. So this is a quadratic inequality. So you have a quadratic expression greater than 0. So how do we solve this? Again, we use our basic concepts. We try to convert this inequality into linear inequality. We try to convert one quadratic inequality into a set of linear inequalities. Something like, for this, we use our concept of factorization. So you know how to factorize quadratic expressions. So what I do is, so x square minus 5x plus 6 can be factorized into x minus 2 into x minus 3 greater than 0, right? I don't think I need to explain you how to factorize. You know how to factorize quadratic expressions. So once you factorize this, x minus 2 into x minus 3 greater than 0. So this becomes something called a factorized inequality. So till this point, it is a quadratic inequality, just a quadratic inequality. Here, it is a factorized quadratic inequality. So this has been factorized into linear factors. So after doing this, it is very easy to solve this inequality. So how do I do this? I analyze it like this. So this is a product of two numbers. This is a product of two numbers, x minus 2 into x minus 3. And the product of two numbers has to be positive. The product of two numbers has to be positive. This implies either both the numbers are positive, or both the numbers are negative. This is how we analyze this. So either both the numbers are positive or both the numbers are negative. So this implies x is greater than 2 and x is greater than 3, or x is less than 2 and x is less than 3. So this implies, I'll plot this solution on a real number line. If you have a real number line, what this says is, if you have a 2, if you have a 3 on the real number line, one solution says that x should be greater than 2. The other says that x should be greater than 3. So what is the common solution for this? X is greater than 3 is the common solution. Or, so if you take the next solution, so it says that if you have 2 and 3, x is less than 2 and x is less than 3. This and this, both of them have to be satisfied. So what is the common solution? X is less than 2. So now in between these two, you have an or. That means x is greater than 3 or x is less than 2. That means or represents union. So you have to take either this solution or this solution. So what is the effective solution? The effective solution is something like this. If you have 2 and 3, x is greater than 3 or x is less than 2. So both these intervals represent the solution of this quadratic inequality. That means once you factorize this inequality, you can convert this inequality into a series of linear inequalities and solve this. So to do this consistently and easily without actually solving this, so wavy curve method is a shortcut method to do this. So now what is this wavy curve method? So let us try to understand this process. So let us take the same example, x square minus 5x plus 6 is greater than 0. Now, before using this wavy curve method, we need to factorize this inequality. So wavy curve method is a method to solve factorized inequalities. So you need to remember this. To use wavy curve method, first you need to factorize the given expression. And if it is already factorized and given to you, it's very good. Otherwise, you need to factorize it. So let us factorize this. X minus 2 into x minus 3 is greater than 0. So now you're ready to use the wavy curve method. So in this method, the first thing that we do is we make all the leading coefficients in each factor as positive. That's the first step. So now if you see the first factor, this is x minus 2. That's the first factor. What is the leading coefficient? Leading coefficient is the coefficient of the highest power of x. So here the highest power of x is x power 1. So what is the leading coefficient? Plus 1. It's already positive. X minus 3, the leading coefficient is plus 1, already positive. So if in this question, the first step has already been done. So if the leading coefficients are not positive in some of the factors, we first make them positive by multiplying with a negative sign if it is required. So we make all the leading coefficients of each factor positive. The second step is we identify critical points. Critical points are the points where the factor becomes 0. Here x minus 2 is a factor. Where is x minus 2 becoming 0? At what value of the variable x minus 2 is becoming 0? X is equal to 2. At what value of x is this factor becoming 0? X is equal to 3. So identify critical points. For this question, x is equal to 2 and x is equal to 3 are the critical points. Now, in the third stage, we draw wavy curve. So how do we draw this? So here, we take the real number line. And plot the critical points on this real number line. So what are the critical points? 2 and 3. So one is 2, the other is 3. That's the critical points. So now what we do is the rightmost side. So when you have two critical points, the real number line will be divided into 3 parts. So in the rightmost part, start from the positive side. So you start from above, and at each critical point, just change the sign. That is, at 3, on the right side of 3, the curve is on the positive side. On the left side of 3, the curve comes to the negative side. And here, the curve is approaching 2 from the negative side. So it goes to the positive side. So at each of the critical points, just change the sign of the curve. At each critical point, the curve meets x-axis and changes sign. So once the wavy curve is drawn, so this, wherever the curve is above the real number line, the sign is positive. Have sign negative, the sign is positive. So now once you have the wavy curve, so you want x minus 2 into x minus 3 to be positive. So you should look for the positive interval. For what values of x's? The curve is above x-axis. So as you can see, x should be less than 2 or x should be greater than 3. That's the answer to this equation. Inequation using wavy curve method. So this question can be very easily solved using wavy curve method. So as you can see, this is a very nice shortcut. So let us try to analyze this shortcut in a more detailed way. So this is just an introduction for this shortcut. So what are the situations in which you can use this wavy curve method, and what are the pitfalls, what are the things that you need to be careful about in this applying this wavy curve method? We'll look at it now. So now let us look at the concept of wavy curve method more clearly. So wavy curve method is used to solve factorized inequalities of any power, any degree. Suppose you have an inequality of the form x minus a1 power alpha 1 into x minus a2 power alpha 2 into x minus a3 power alpha 3, so on x minus an power alpha n. If this is a factorized expression, if you want to solve this expression greater than 0, where a1, a2, a3 up to an are in increasing order. So how do we use wavy curve method to solve this? So the first step is we identify all the critical points because the leading coefficient has already been done positive. So first you need to make all the leading coefficients positive. Once it is done, next we plot all the critical points on the real number line. So assume that you have 5 critical points, for example. So A5. Next, if you have 5 critical points, the real number line will be divided into 6 parts. So now on the rightmost part, you start from above the line, above the real line. And at each point, so if you are checking at A5, so what you need to check is corresponding to the factor x minus A5, you have to check the power of this factor. So if the power is even, the sign does not change. If the power is odd, the sign changes. Remember this very carefully. The power is odd, sign changes. Sign changes. Power is even, the sign does not change. So, for suppose x minus A5 power 3. So, if you have x minus A5 power 3, the power is odd, hence the sign changes around A5. The sign of the curve changes around A5. That is, on the right side of A5, the curve is on the positive side. On the left side of A5, the curve goes to the negative side. So, suppose to see what happens at A4, you need to see the power of x minus A4. Suppose x minus A4 has a power of 5. So if it is an odd power, again the sign changes. That is, from the negative side, the curve is going to the positive side. So now to see what is happening at A4, you need to check the sign of the power of x minus A3. So for suppose x minus A3 has a power of 4. That means the power of x minus A3 is even. And the sign of the curve does not change around A3. That means the curve goes like this. That is, the curve is positive on the right side of A3. The curve is positive on the left side of A3 also. Now, if you go to A2, so at each point you need to check the power of the factor. You have x minus A2 power 2. So here also the sign does not change. So you can have it like this. And for suppose if you have x minus A1 power 7, you have an odd power, so the sign changes and goes down. So this will be how the wavy curve looks like. And wherever the curve is above the real line, that means the sign of the expression is positive. That is, the sign of the expression is positive, the expression is greater than 0. Wherever the curve is below x-axis, the expression is negative. So this is how we solve inequalities, factorized inequalities using wavy curve. So let us apply this wavy curve in different situations now through examples. So let us look at these two questions. Let us see how we can solve this inequalities using wavy curve method. So as you see these questions, does they come under the topic of factorized inequalities? Yes, because they are already factorized and given to you. So x minus 1 into x minus 2 into x minus 3 greater than 0. Now, what is the first step of wavy curve method? In the first step, we make all the leading coefficients in each of the factor as positive, which has been already done. Which has been already done because all the leading coefficients are plus ones, all are positive. Now, in the second step, what we do is we identify the critical points. The critical points are the points where each of the factor is 0. That is 1, 2 and 3. This factor is 0 at x is equal to 1. This factor is 0 at x is equal to 2. This factor is 0 at x is equal to 3. So once you identify the critical points, now we go to our wavy curve where we draw the real number line and identify the critical points on the real number line. And we start from above x-axis on the rightmost interval. You have 4 intervals. So in the rightmost interval, we start from the positive direction, that is from the top. Next, we come to x is equal to 3. All the powers, as you can see, of each factor are odd. That means the sign change happens at each of these critical points. So the wavy curve can be directly drawn like this. At each point, the sign is changing. That is, at the first point 3, the curve is going from positive side to negative side. At x is equal to 2, from negative side to positive side. At x is equal to 1, from positive side to negative side. So this is the wavy curve. So once you have this, wherever the wavy curve is above x-axis, that is the positive interval. Wherever the curve is below x-axis, that's the negative interval. So what is the answer to this inequality? I want this inequality to be positive. That means these intervals are required. So x belongs to 1, 2 union 3, infinity. That's the answer to this inequality, as a solution to this inequality. So now let us go to the next question. Similar question. This is also factorized. So x minus 1 into x minus 2 whole square into x minus 3 greater than 0. So for this question also, the first step has been already done. All the leading coefficients are 1. So now let us directly go to the second step. What are the critical points? 1, 2 and 3. These are the critical points. Now let us go to the third step. Let us draw the wavy curve. Let us identify 1, 2, 3. So you're starting from above the real number line. You start from this. So what happens at 3? So the power of x minus 3 is odd. That means sign change happens at x is equal to 3. What happens at x is equal to 2? X minus 2, the power is even. That means the sign does not change at x is equal to 2. That means the curve which comes from the negative side again goes to the negative side. Next, let us see what is happening at x is equal to 1. For that, we need to see the power of x minus 1. It is 1. So, odd number. So the sign changes. That means the curve goes from negative side to positive side. So now the curve is above x-axis in this interval and in this interval, minus in these two intervals. So I want this expression to be positive, greater than 0. So what is the solution for this? X belongs to minus infinity to 1, minus infinity to 1, union 3 to infinity. That's the answer to this question. So now let us look at some more examples so that you can become comfortable with the wavy curve method. So now let us look at these questions. So 4x minus 3 into 5 minus 2x whole square into 4 minus x whole cube is less than 0. This is also a factorized inequality. So for this, what I do is first I'll observe the individual factors. 4x minus 3, the leading coefficient is plus 4. It's okay. 5 minus 2x, the leading coefficient is minus 2, negative number. And 4 minus x, the leading coefficient is minus 1, negative number. So first I'll try to make this negative leading coefficients into positives. So 4x minus 3 into, so I say that you have to make leading coefficients from negative to positive. It's not that you just need to make it into plus. You have to be logical. So 5 minus 2x whole square, because the power is even. 5 minus 2x whole square, if I write 2x minus 5 whole square, if I take a minus common, so outside you get minus 1 whole square, which is same as 1. That means 5 minus 2x whole square is same as 2x minus 5 whole square. And from 4 minus x, if I take a minus outside, so you get minus 1 whole cube, which is a minus. So you have an extra minus of x minus 4 whole cube is less than 0. So now you have made all leading coefficients into positive, but you have an extra minus sign here. So I uniformly multiply both sides with minus 1. So it becomes 4x minus 3 into 2x minus 5 whole square into x minus 4 whole cube. What happens if you uniformly divide both sides, uniformly multiply both sides with a negative number? The sign of inequality changes. Just remember this. It's very important. The sign of inequality changes. So now once you have this inequality, now this comes under the standard inequalities. So next, first stage has been done. All the leading coefficients are positive. Now let's go to the second stage, identification of critical points. It is, where is 4x minus 30? X is equal to 3 by 4. Where is 2x minus 50? X is equal to 5 by 2. Where is x minus 40? X is equal to 4. So you got the critical points. Now let us draw the wavy curve. So let us plot this on the real number line. We know that 3 by 4 is less than 5 by 2 is less than 4. So once you have plotted this, the real number line has been split into 4 parts, right? So in the rightmost part, you start from above the real number line. So what happens at x is equal to 4? What is the power of x minus 4? Odd power. That means the sign is changing. That is, the curve goes from positive to negative. What is happening at 5 by 2? The corresponding factor is 2x minus 5. The power is even. That means sign does not change at x is equal to 5 by 2. That means the curve is approaching from the negative side. It again goes to the negative side. What is happening at 3 by 4? The power is 1, correspond to this factor. That means the sign changes. So it goes from negative side to positive side. So the wavy curve is completed. Positive interval, negative, positive. So what is the answer that you want? Do you want negative or positive? So you want it to be positive, right? Because once you change this inequality, the inequality effectively has become this. So you should not see this now. You have to see this. We have drawn wavy curve for this inequality. So I want my inequation to be greater than 0. So that means I want the positive intervals. So x is less than 3 by 4 or x is greater than 4 is the answer. Minus infinity to 3 by 4 union 4 to infinity is the answer. Now let us go to next inequation. 4 minus 3x whole cube 2 plus x into 5 minus x whole square is greater than 0. So here also the problem is some of the leading coefficients are negative. So let us take a minus common. So 3x minus 4 whole cube, if you take a negative common, so you get minus 1 whole cube, you get an extra minus. 2 plus x is same as x plus 2, you are not doing anything special for this. 5 minus x whole square. So if you take a minus 1 common, it becomes x minus 5 whole square. And you get a minus 1 whole square outside. Minus 1 whole square is plus 1. So greater than 0. So you have a minus here. So uniformly you multiply with minus 1. So you get 3x minus 4 whole cube into x plus 2 into x minus 5 whole square is less than 0. So if you take both sides, if you multiply both sides with a negative sign, the sign of inequation changes. So you have this. Now, this is a standard factorized inequation. You can use wavy curve method. The first step is already done. So the second step is identification of critical points. You get 4 by 3 for this. You get minus 2 for this. You get plus 5 for this. So let us plot our wavy curve. So minus 2 is here. 4 by 3 is somewhere in between. 5 is at the last. So you start from above the real line. What is happening at x is equal to 5? X minus 5 whole square, the power is even. So the curve moves up. Next, what is happening at 4 by 3? This corresponds to 3x minus 4. The power is odd. That means the sign changes. What is happening at x is equal to minus 2? What is happening at x is equal to minus 2? The power is odd and the sign changes. So this goes above. So this is the positive interval. This is the negative interval. So what is the interval that I want? I want the negative interval, right? So I'm solving this inequation. So what is the answer? X belongs to minus 2 comma 4 by 3. So that's the solution to this inequation. So now let us see further more examples. So now let us look at still more examples. So let us see this question. X minus 4 into x square plus 1 into x minus 3 whole square is less than 0. So the first question is this a factorized inequality? So x minus 4 is a linear factor. X minus 3 whole square is also a linear factor. But x square plus 1 is a quadratic factor. So I cannot directly apply the wavy curve method unless I am sure about this factor. So what is the nature of this factor? So can I further factorize this? So x square plus 1 is a quadratic factor, quadratic expression. So can it be further factorized into two separate linear factors? No, because for x square plus 1, the value of delta A is b square minus 4ac. So b square is 0, minus 4ac is minus 4. It is delta is negative. That means this factor cannot be factorized. And we know that from the theory of quadratic expressions, this expression is always positive. So x square plus 1 is a quadratic factor. If delta is negative and the leading coefficient is positive, then the expression is always positive. You can be sure about it. You'll understand this in the theory of quadratic expressions. So now, if this expression is always positive, so you can cancel this out because the left hand side is 0. So if the number is, you're sure that this number is positive, you don't need to take this into account at all. So the effective inequality depends on just x minus 4 and x minus 3 whole square. So I can as well write this as x minus 4 into x minus 3 whole square is less than 0. So this is a very important simplification that you do. Whenever you have quadratic factors, you can either factorize them, you can either try to factorize them, or if the delta is negative and the leading coefficient is positive, delta is negative and the leading coefficient is positive, the expression is always positive. You can neglect this. So now you have a simple inequality. So you have 3 and 4 as the critical points. You start from above x-axis. At x is equal to 4, the power is odd, so the sign changes. X is equal to 3, the power is even, so the sign does not change. So this is the wavy curve, negative, negative, positive. I want my inequality to be negative. So x belongs to minus infinity to 3 union 3 to 4. So that's the answer to this inequality. So if you go to the next inequality, here also you have a quadratic factor. But can you see here also that what is the value of delta of this? B square is 1 minus 4, that is minus 3. Delta is negative and the leading coefficient is 1. Leading coefficient is positive. Hence this expression is always positive. So you can cancel this out. So the expression becomes x minus 5 whole square into x minus 2 is less than 0. So the wavy curve becomes something like this, minus 5 for this, 2 for this. So I start from above x-axis. At x is equal to 2, the sign changes, so this becomes negative. And x is equal to minus 5, the power is even, so the sign does not change. So it comes from negative side and goes to the negative side only. So this is negative side, this is negative side, this is positive side. Negative, negative, positive. So I want my inequality to be less than 0. So x belongs to minus infinity comma minus 5 union minus 5 comma 2. So this is the solution to this inequation. So by now you have understood how to use wavy curve method. You have understood how to use wavy curve method in different situations. And in this topic, you are trying to understand why that method works. So why is this wavy curve method working? So what is the rationale behind this? So to understand that, let us take a sample equation. So let us try to understand using example itself. So let us take a simple linear inequality. Let us take x minus 1 into x minus 2 whole square into x minus 3 greater than 0 and try to solve this logically. So how do we analyze this? So first we know that this expression will be equal to 0 at x is equal to 1, x is equal to 2, x is equal to 3, right? So whatever I'm calling as critical points, those are nothing but zeros of the polynomial. This is a 4-degree polynomial effectively, which has been already factorized. So what are the zeros of this polynomial? 1, 2, and 3. That means the value of this polynomial is 0 at these 3 points. So if you draw the graph of this, so when x is equal to 1, x is equal to 2, x is equal to 3. So at these 3 points, the curve cuts x-axis, we know this. So at the zeros of the polynomial, the curve cuts x-axis. Now, the question is, how does this cut? So let us see what is happening at x is equal to infinity. So if x is equal to infinity, that is a very large number. When x is a very large number, x minus 1 is positive, x minus 2 whole square is positive, x minus 3 is also positive. Let us take x is equal to 1000. 999, 998 whole square into 997. All the 3 numbers are positive. Hence the product of these 3 is positive. So when x is a very large number, so the expression is positive. That means the graph lies above x-axis. This happens because all the leading coefficients are positive. So by making all leading coefficients positive, what I am doing is, when x is a very large number, so I am making the expression to be positive. So the expression, the value is positive when x is a very large number. So we know that the graph of a polynomial is always continuous also. So it becomes 0 here. It is positive on the right side of 0. So the graph has to come and cut 3 somewhere here. And after the graph touches 3, touches x-axis at x is equal to 3, it has 2 options. It can either go back like this, it can touch the graph at x is equal to 3, or it can cut the x-axis. So it has 2 options. So which option does it take? So if it takes this option, that means between x is equal to 2 and 3, the value of the expression has to be positive. If it takes this route, that means between x is equal to 2 and 3, the graph is, the value of the expression is negative. So let us see what happens between x is equal to 2 and 3. So let us take any number between 2 and 3. Let us take 2.5. So let us check the signs of individual factors. So 2.5 minus 1 is positive. 2.5 minus 2 whole square is positive. 2.5 minus 3 is minus 0.5 is negative. If I multiply these 3 numbers, positive into negative, obviously is a negative number, hence sign is changing. Since this will be the route that the actual curve takes. That means the sign is changing on the either side of x is equal to 3. So this is happening because the power of the degree of x minus 3 is odd. Because x minus 1 and x minus 2, the signs does not change around 3. The sign of x minus 1 changes around x is equal to 1. The sign of x minus 2 whole square changes around x is equal to 2. Around x is equal to 3, the sign of x minus 3 changes because the power is odd. So here, all the expressions are positive. Here, the first 2 expressions are positive, but the last expression is negative. Hence, the sign changes. So let us come to x is equal to 2. So let us see what happens at x is equal to 2. So around x is equal to 2, what are the signs? So between 1 and 2, the sign of x minus 1 does not change around 2. So it is positive even now. X minus 3, the sign does not change around 2. The sign has already changed. So this becomes negative. So what is the sign of x minus 2 whole square? So whatever the sign of x minus 2 is, the sign of x minus 2 has become negative. But when you square it, it has become positive again. That means the sign are not changing because the power is even. That means it comes back again to the negative side. And at x is equal to 1, x minus 1 factors sign change. So this plus will become minus and these 2 signs will remain as it is. So minus into minus is positive. So the graph comes onto the positive side. So this is how the graph looks like. This is positive, negative, negative, positive. Hence, if you want this expression to be positive, my answer should be x belongs to minus infinity to 1 union 3 to infinity. So that will be the answer to this question. So once you understand this concept of sign changes, you can as well apply this wavy curve method in different situations involving functional inequalities. Functional inequalities. So let us further inquire into wavy curve method using certain examples. So let us look at these two inequations. So in these inequations, apart from polynomials, you also have some expressions involving functions, exponential functions, e power x minus e, so on. Now, so what are the critical points of these functions? So the critical points of the expressions are x is equal to 1, 2, 3, and for this factor, the critical point will be the value of x where this expression is 0. That is e power x minus 1 has to be equal to 0. That is e power x is equal to 1. That is x is equal to 0. So for this, x is equal to 0 is a critical point. Now you have 4 critical points. So let us plot them on the real line. It is 0, 1, 2, 3. Now let us draw the wavy curve for this. All the leading coefficients are positive. That means when you put x as a very large number, each of these expression is positive. That means the graph starts from above the x-axis. So the fact that I'm saying to make leading coefficients positive is simply what I'm doing is when x is equal to infinity, when x is a very large number, I'm making all the expressions as positive. So you can also as well check this. Put x a very large number, see whether each expression is becoming positive. If that is happening, start from above the x-axis. So what is happening at x is equal to 3? At x is equal to 3, the sign of this changes because the power is odd. All the remaining numbers, all the remaining expressions, sign does not change at 3 because their critical point is not 3. So at 3, the sign changes, it becomes downward. At x is equal to 2, you have the factor x minus 2, but the power is even. Hence, it touches and comes back. And what is happening at x is equal to 1? The power is odd, hence the sign changes again. And what is happening at x is equal to 0? You have x is equal to 0 is the critical point for e power x minus 1 is equal to 0. So you can just check what is happening to the sign of this on either side of 0. So if x is greater than 0, e power x is greater than 1. So you have this number positive. If x is less than 0, you have this number less than 1. So this expression is becoming negative. That means the sign is changing. Hence, the sign changes around x is equal to 0. So this is the wavy curve. So you can as well use this with functional expressions also. So you have negative, positive, negative, negative, positive. I want it to be positive. So x belongs to 0, 1 union 3, infinity is the answer. So let us go to the next expression. So x minus 1 whole square into x minus 2 into e power x minus e is less than 0. So what are the critical points? So for this x is equal to 1, for this x is equal to 2, and e power x minus e is equal to 0. That is e power x is equal to e, x is equal to 1. So 1 is a critical point for this as well as this. And x minus 2 is the critical point for this. So if you draw the wavy curve, you have only 2 critical points, 1 and 2. So all the leading coefficients are positive. Or when x is a very large number, all the expressions are positive. So you start from here. What is happening at around x is equal to 2? So the power is odd, the sign is changing. Now what is happening at x is equal to 1? The power of this is even. So the sign does not change because of this. But 1 is also a critical point for this. So effectively, the power of the criticality of 1 is 3. Or this expression is changing sign, because if x is greater than 1, this is positive. When x is less than 1, this expression is negative. So this factor is changing sign around 1. This factor is not changing. So the multiplication of these two changes sign, right? So at x is equal to 1, it changes sign. So this is plus, minus, plus. So I want this expression to be negative. So the answer is x belongs to 1, 2. So similarly, instead of exponential function, you can have logarithmic functions, you can have trigonometric functions, so on, whatever you have. So you can analyze it in the same way. So around the critical point, you just need to analyze this change of sign. So just change the variable, something like this. When x is greater than 1, what is happening? When x is less than 1, what is happening? So if you can analyze these two, you can easily solve the functional inequalities also, as long as they are factorized. So now let us go further. So let us look at this example. E power x minus 1 into sin x minus half into log x minus 1 is greater than 0. Again, this is a functional inequality, right? So for this, also we can use wavy curve method. First, let us identify the critical points. So let us identify the critical points. E power x minus 1 is equal to 0 implies x is equal to 0, right? Because e power 0 is equal to 1. X is equal to 0 is a critical point. Next, sin x is equal to half. Sin x is equal to half. You're asked to solve in 0 to 2 pi. Whenever you get trigonometric functions in the inequalities, you'll be asked to solve within a particular interval, because sin x goes on changing sign indefinitely. So sin x is equal to half implies x is equal to pi by 6 and 5 pi by 6. These are the two solutions. Next, log x to the base e. Log x to the base e is equal to 1. This implies x is equal to e. So x equal to 0 is the critical point for this. X is equal to pi by 6 and 5 pi by 6 are the critical points for this. X is equal to e is the critical point for this. So now let us draw the wavy curve. So I'm starting with 0 because I don't need the solution before 0. So I want the solution between 0 and 2 pi. 0. And you know that pi by 6, pi is 3.14, right? 3.14 by 6, something like 0.4 something, 0.5 something. So pi by 6 lies somewhere here. Next, e is 2.71, so on. And 5 pi by 6. So what is the approximate value of 5 pi by 6? You need to know the relative positioning of these points. So 5 into pi by 6 is 3.14 by 6. Something like 15.7 by 6. 15.7 by 6. 2.37. 6 to 2.62. This is 2.71. So 5 pi by 6 lies before the value of e. And after e, 3.14, 2 pi is 6.28. 2 pi lies somewhere here. So you're asked to solve within this interval. So now we don't say we have to start from above x-axis or below x-axis, below the real number line or above the real number line. Now we check at some interval. So let us check in this interval. So let us start from this. Let us check in this interval. So in this interval, 0 is the point where this becomes 0. That means the wavy curve starts from this. So you have to see whether it goes up or it goes down. And it's between this interval. If the expression is positive, it goes up. If the expression is negative, it goes down. So when x is greater than 0, my first expression is positive, right? This expression is positive. Around x is equal to 0, sin x is close to 0. So sin x minus half is negative, right? And around x is equal to 0, log x is negative infinity. So minus infinity minus 1 is also negative. So the first expression is positive, The other two expressions are negative. So if you multiply these three, positive into negative is positive. So you have to go up. Now, what is happening at x is equal to pi by 6? Around x is equal to pi by 6, sin x minus half is changing sign. Because at x is equal to pi by 6, it is sin x is exactly equal to half. After pi by 6, it becomes greater than half. Before pi by 6, it is less than half. So the sign of sin x changes. The remaining signs don't change. Hence, only one expression is changing sign, and the sign of the expression changes. So now as we go further, at x is equal to 5 pi by 6, again, only the sign of sin x minus half changes. The other two signs does not change because they are not the critical values for these two expressions. So one expression is changing sign, hence the sign, effective sign changes. And what happens at e? The sign of log x to the base e minus 1 changes. And x is greater than e, this is positive, and x is less than e, this is negative. So if I have to write the signs, I can write it like this. The first expression is positive here. So sin x also becomes positive here, and this is negative. So the expression is negative in this interval. So once you come to this interval, sin x sign again changes. That is plus, minus, minus. So the effective expression has become positive. So now what is happening after e? After e, my last expression is also becoming positive. That is, first expression is already positive. The second expression is continuing to be negative. The third expression has become positive. Hence, the effective sign plus into minus into plus is negative. And this goes to the negative side. And 2 pi is not a critical value for any of this. That means at 2 pi the curve does not meet the axis also. So it goes on going like this. So it might meet the axis at some other point where sin x is equal to half again in the fifth quadrant, that is in the first quadrant again, 2 pi plus pi by 6. The curve meets the x-axis. But you are only concerned from 0 to 2 pi. So what is the signs? Plus, minus, plus, minus. So I want my expression to be positive. So x belongs to 0, pi by 6 union 5 pi by 6 to e. So this will be the solution for this inequation. So I hope you have understood the wavy curve method for quadratic and polynomial inequalities. So now let us go further for rational inequalities also. So now that we have understood how to use wavy curve method for quadratic and polynomial inequalities, so let us see how to use wavy curve for rational inequalities. So for example, so if you have the inequality x minus 2 by x minus 3 is greater than 0. So x minus 2 by x minus 3 is greater than 0. So what is the solution for this rational inequality? So this is called rational inequality because it has a numerator and a denominator. X minus 2 by x minus 3 is greater than 0. So let us see how to solve this. So again, the steps are similar. So the first step is make all leading coefficients as positive, which has already been done in this inequality. And next, so in the next step, in normal inequations, we find the critical points, right? We find the critical points. In rational inequalities, critical points are divided into two categories. The first are zeros of this rational expression, and the second is poles. First is zeros and the second is poles. Zeros are the points where the factors in the numerator become 0. Numerator factors become 0. So these are called the zeros of the inequation. And poles are the values of x where the denominator factors become 0. So zeros are the points where the expression becomes zeros, and Poles are the points where the expression becomes undefined. So that's the difference between the zeros and the poles. So both are critical points. And third, so we draw the wavy curve, mostly similar to what we have done in the previous sections. So if you see the wavy curve for this, so the critical points are x is equal to 2 and x is equal to 3. So out of this, x is equal to 2 is the 0, x equal to 3 is a pole. So whatever are the poles, we take a hollow dot here. That means this 3 will not be the solution for any of the inequality, because at 3 the expression is undefined. And once you identify the poles with hollow dots, the remaining wavy curve remains same. That is, we start with above x-axis and we change sign depending on whether the power is even or odd. Both the powers are odd, that means you have a sign change. So it is positive here, negative here, positive here. So I want my expression to be positive. That means the solution is x is belonging to minus infinity comma 2 union 3 comma infinity. Anyway, there is no equality here, hence we have open intervals. So let us apply this method for further rational inequations. So if you look at these examples, so we solve these rational inequalities exactly the same way that we have solved polynomial inequalities. So these are also factorized already. These are linear factors. So 2x minus 3 by 3x minus 5 greater than or equal to 0. The first step, make all the leading coefficients as positive. That has been already done. And the second step, identify the critical points. In this, we make a distinction. X is equal to 3 by 2 is a 0 of this polynomial. X is equal to 5 by 3 is a pole of this polynomial. So once you have identified the critical points, let us draw the wavy curve diagram. So you have 3 by 2 and 5 by 3. 3 by 2 is 1.5, 5 by 3 is 1.66. So 3 by 2 is on the left side, 5 by 3 is on the right side. So let us start from above the x-axis because all the leading coefficients are positive. So you start here. The powers are both odd, so you have sign changes at both of these points. And at poles, we make a hollow dot. And this will not be the solution for any inequality because at this point, the expression is undefined. So now what is the solution for this? This has to be positive. Plus, minus, plus. Now you have equality also. That means the expression can be equal to 0 also. So x belongs to minus infinity to 3 by 2 closed because at 3 by 2 the expression is becoming 0. Union open 5 by 3 to infinity. Why is it open? Because 5 by 3 cannot be included in any of the solution because at 5 by 3 the expression is undefined. So this will be the answer. Next, if you go here, x square by x minus 5. So what are the critical points? So if you take the first step, the leading coefficients have been already made positive. The first step is done. If you take the second step, critical points. So zeros are x is equal to 0. Pole are x is equal to 5. You have one pole and one 0. These are the zeros, these are the poles. So once you have these two, let us draw the wavy curve. This is 0, this is 5. At pole, you have to make a hollow dot. And start from above. So x minus 5 has power 1, x has power 2. So there is a sign change at x is equal to 5. There is no sign change at x is equal to 0. Negative, negative, positive. So I want my expression to be less than or equal to 0. Equality is also valid. That is, x is equal to 0 is also valid. So x belongs to minus infinity comma open 5 is the answer. It can be 0 also. So minus infinity to 5 open is the answer to this question. Let us go to the third one. So in this question also, the first step has been done because all the leading coefficients are positive. And next, once the leading coefficients are positive, identify the zeros and poles. So the zeros are 1 by 2 and 1, right? X is equal to 1 by 2 and x is equal to 1. The poles are 2 and 4. Now let us draw the wavy curve for this. So let me draw it here. So let me plot all these points here. So half, 1, 2 and 4. And at poles, I am making a hollow dot. At 2 and 4, I am making a hollow dot. Now how does the wavy curve look? It starts from above the x-axis. At x is equal to 4, you can see the power is even. So it does not change sign. At x is equal to 2, the power is 1 and the sign changes. At x is equal to 1, the power is 4 even and the sign does not change. At x is equal to half, the power is odd and the sign changes. So plus, minus, minus, plus, plus. So this inequation, I want the negative interval. I want this inequation to be less than or equal to 0. That means I want the negative interval, right? So x belongs to half should be closed because equality is also valid. So half 2. This 1 is okay. You don't need to separate at 1. So it is uniformly negative and it happens till 2. But 2 is a pole, hence you need to write this as the answer. X belongs to half comma open to, closed half comma open to. So now that you have seen the different situations where wavy curve can be used, let us summarize the wavy curve method. So first thing that you need to understand is wavy curve method can be used for QPR inequalities. That is quadratic, polynomial and rational inequalities. So wavy curve method can be used for these three types of inequalities. And the inequalities that we are going to solve have to be factorized inequalities. So only if the inequality can be factorized into linear or quadratic factors, then wavy curve method can be used. And you have steps that you need to follow for wavy curve method. Wavy curve method has 3 to 4 steps. The first step is leading coefficient positive, make leading coefficient positive. And the second step is identify the critical points. For polynomials, all the critical points are the zeros. For rational inequalities, critical points are of two types, zeros and poles. You need to differentiate between these two. And third, just need to draw the wavy curve for the inequality, keeping in mind the odd powers and even powers. So if you have an odd power, remember that sign changes. If you have even power, remember that the sign does not change. So once you remember this, wavy curve can be drawn for any of quadratic, polynomial and rational inequalities. So and finally, wavy curve method can also be used for functional inequalities if they look related to linear factors. So you just need to find the critical points and observe the signs on either side of the zeros. So if you can do that, it can be used for functional inequalities also. So I hope you have understood the crux of this wavy curve method. And I hope you will be able to apply this while solving different linear inequalities. So now, let us look at the topic of functional inequalities. So this type of inequalities involve certain standard functions. So the first type of functional inequality are the inequalities involving modulus function. So we know the definition of mod x. F of x is equal to mod x. So what is the definition of mod x? Mod x is a piecewise defined function which is equal to x if x is greater than or equal to 0. Mod x is equal to the same number as x if x is a number which is greater than or equal to 0, minus x if x is less than 0. That's the definition of mod x. That is, if you have mod of 2, this is exactly equal to 2 because 2 is positive. What is mod of minus 2? Mod of minus 2 is equal to minus of minus 2. Because this minus 2 is negative, you add one more minus to it. So minus of minus 2 becomes 2. So effectively, whether x is positive or negative, the output will always be positive. So now, once you understand the definition of mod function, so what are the types of inequalities that you encounter using this modulus function? So, types of inequalities that you get. So, let me chalk out the basic types. So, mod x is less than a. Mod x is less than a. So, example, if you have mod x is less than 2, so what should be the solution for this? So, if mod x is less than 2, then x belongs to the set minus a to plus a. That's the solution for this. That is, if mod x is less than 2, that means the value of x, the absolute value of x should be less than 2. So, on the positive side, if x is in between 0 to 2, if x is belonging to 0 to 2, mod x is in between, mod x is less than 2. Similarly, if x is belonging to close 0, minus 2 comma 0, on the negative side, if x belongs to minus 2 comma 0, also after taking mod, you get a number which is less than 2. So, mod x less than 2 implies x belongs to minus 2 comma plus 2. You need to remember this. This is a very frequently asked inequality. If mod x is less than a, then x belongs to minus a to a, provided a is a positive number. And if a is a negative number, x belongs to null set if a is negative. Mod x can never be less than a negative number. If I say mod x is less than minus 2, mod x can never be negative, so how can it be less than minus 2? That means x belongs to null set. There is no solution for this. So I hope you are clear about the first type of inequality. And the parallel for this is mod x is greater than a. So if you have equality here, you have a closed interval here. So mod x is greater than a. So what is the answer to this? If mod x is greater than a, x is either greater than a or less than minus a. So on the positive side, if x is greater than a, then mod x will be greater than a. On the negative side, if x is less than minus a, also mod x will be greater than a. So if mod x is greater than 2, this implies x should be greater than 2 or x should be less than minus 2. These are the two options that you have. So mod x greater than a implies x is greater than a or x is less than minus a. So if a is positive and if a is negative, x belongs to real numbers if a is less than 0. So if I say mod x is greater than minus 2, so mod x will be greater than minus 2 for all x belongs to real numbers. Because mod x is always positive, every positive number is greater than minus 2. So I hope you have understood the first two types of inequalities. Mod x is less than a, mod x is greater than a. Mod x is less than 2, mod x is greater than 2. for example. So now let us go to the further inequalities. So the next type of inequality is something like mod x is in between a and b. Mod x belongs to a comma b. That is, a less than, you can have equality also, a less than or equal to mod x less than or equal to b. Mod x lies between a and b. Let us assume that a and b are positive numbers. A comma b belongs to positive real numbers. Now what is the solution for this? So if mod x lies between a and b, there are two options. So if x is positive, mod x is equal to x. So x has to lie between a and b. X has to lie between a and b. Or if x is negative, so minus x can lie between a and b. That is, x lies between minus b to minus a. These are the two options. That is, for example, if mod x lies between 2 and 3, so what can you say about x? So x can lie between 2 and 3. If x lies between 2 and 3, mod x also lies between 2 and 3. Or x can lie between minus 3 and minus 2. So these are the two options that you have, either 2 or 3 or minus 3 to minus 2. So you have three types of inequalities. Mod x is less than a, less than or equal to a, greater than a, greater than or equal to a, between a and b, less than or equal to, greater than or equal to a and b. So this is when a is positive. A and b are positive. If a and b are negatives, this does not have any solution. If one of it is positive and the other is negative, then you can have different solutions. So, and the fourth type of inequality that you might encounter is mod x is greater than or equal to mod y. So, you might have two mods on either side of the inequality. So, if mod x is greater than or equal to mod y, the solution of this is exactly same as the solution of x square greater than or equal to y square. Because mod and mod, both these numbers are positive. So once these two numbers are positive, I can square them. So mod x greater than or equal to mod y is exactly same as x square greater than or equal to y square. You can convert this into a quadratic inequality and solve it using wavy curve or so. So let us look at some examples. So first, mod of 2x plus 3 is less than 5 or less than or equal to 5. You are asked to solve this inequality. So how do you solve it? So let us use our basic concepts. So if mod of x is less than or equal to a, this implies x is in between minus a to plus a. So this is the statement that we have understood. So here you have mod of something. So inside mod, the number need not always be x. X can be read as something. If mod of something is less than or equal to a, then that something has to lie between minus a and plus a. So mod of 2x plus 3 is lying between, is less than or equal to 5. So this something which is inside mod 2x plus 3 has to lie between minus 5 and plus 5. Now this has become a linear inequality. You know how to solve this. So I'll subtract minus 3 on both sides. Minus 8 less than or equal to 2x less than or equal to 2. So x is in between minus 4 and 1. That's the solution to this inequation. So mod 2x plus 3 less than or equal to 5. The answer is x is in between minus 4 and 1. So next, let us look at a slightly more complicated inequality involving mod. This is a rational inequality involving mod. So how do we solve this? So whenever a slightly complicated inequation comes, we use something called the method of intervals. So for mod functions, we use the method of intervals to simplify the function and then use wavy curve. So first what we do is, let me try to simplify this mod of x plus 3. So what is mod of x plus 3? Mod of x plus 3 is same as x plus 3 if x plus 3 is positive, that is x is greater than or equal to minus 3. If x is greater than or equal to minus 3, that is x plus 3 is greater than or equal to 0, mod x plus 3 is same as x plus 3. And minus of x plus 3 if x is less than minus 3. So these are the two cases that you have. So now let us substitute these cases in this inequation. So this inequation can be thought of as two cases. Case 1, this inequation becomes x plus 3 plus x, that is 2x plus 3 by x plus 2 greater than 1. This is when x is greater than or equal to minus 3. And the second case is this mod of x plus 3 is becoming minus x minus 3. So if it becomes minus x minus 3, minus x minus 3 plus x gets cancelled. So minus 3 by x plus 2 is greater than 1 if x is less than or equal to minus 3. So these are the two cases that you have. Solve it separately in both the cases. So let us take this case. This becomes a rational linear inequality. So I'll bring this one onto this side. So 2x plus 3 by x plus 2 minus 1 is greater than 0. This implies, if you take LCM, 2x minus x is x, 3 minus 2 is 1, by x plus 2 is greater than 0. Now this is a rational inequality. I can use wavy curve. So minus 2, minus 1, both the leading coefficients are positive. This minus 2 is a pole. So the curve, wavy curve looks like this: positive, negative, positive. So what is the positive interval? X belongs to minus infinity to minus 2 union minus 1 comma infinity. But this solution is valid only when x is greater than or equal to minus 3. So you have to find the common interval. So when x is greater than or equal to minus 3, this is minus 3. So x has to be on this side of minus 3. So what is the effective solution? So x belongs to minus 3 closed to minus 2 union minus 1 comma infinity. So this is the interval when x is greater than minus 3. So this is one interval. The second interval is minus 3 by x plus 2 is greater than 1. Here also you bring this one onto this side. So minus 3 by x plus 2 minus 1 is greater than 0. Minus 3 minus x minus 2 by x plus 2 is greater than 0. Minus of x plus 5 by x plus 2 is greater than 0. If I send this minus onto that side, x plus 5 by x plus 2 is less than 0. Now I can draw the wavy curve. So if I draw the wavy curve, I have minus 5 minus 2. The wavy curve looks like this: plus minus plus. I want the negative interval. So x belongs to minus 5 comma minus 2. But this interval, this solution is valid only when x is less than minus 3. So minus 3 lies somewhere here. So x has to be less than minus 3. And x is in between minus 5 and minus 2. So what is the common interval? So x belongs to minus 5 comma minus 3. Because minus 3 is okay here. So minus 5 to minus 3. So the solution is either this or this. So what is the union of these two intervals? Minus 5 to minus 3 union minus 3 to minus 2 union minus 1 to infinity. So the effective solution is nothing but minus 5 to minus 2 union minus 1 to infinity. So this is the solution to this inequation. So I hope you have understood the process. So I have systematically applied the things that we have learned. So now if you go to the next inequation, mod of something is greater than mod of something. So how can this be solved? This is exactly same as x plus 3 whole square is greater than 2x minus 1 whole square. This implies x square plus 6x plus 9 is greater than or equal to 4x square plus 1 minus 4x. So let me send all the terms onto one side. So let me send everything onto that side because you have a higher coefficient of x square here. 4x square minus x square is 3x square, minus 4x minus 6x is minus 10x, 1 minus 9 is minus 8 is less than or equal to 0. This is a quadratic inequality. So to solve this using wavy curve, we need to factorize this. So 8 3s are 24. I can write as 12 2s are also. So I can write it as minus 12x plus 2x. So I can write as x minus 4 times 3x plus 2 is less than or equal to 0. So once this has been factorized, we can use wavy curve. So let us draw the wavy curve. The roots are 4 and minus 2 by 3, minus 2 by 3 and 4. So both the leading coefficients are already positive. So just need to draw the wavy curve. The powers are all odd and sign changes at each 0. So the curve is like this, plus minus plus. I want this expression to be negative. That means I want the minus interval. So x belongs to minus 2 by 3. Equality is also there. So closed minus 2 by 3 to closed 4. So this is the answer to this question. So next let us look at this question. Mod of x square plus 6 by 5x is less than or equal to 1. This is also an inequality involving modulus function. So what is the process I am going to use to solve this question? So this inequation is of the form mod x is less than or equal to a. So if mod x is less than or equal to a, we have seen that x has to be in between minus a and plus a if a is a positive number. So here 1 is a positive number. Hence, my inequation becomes x square plus 6 by 5x is in between minus 1 and plus 1. And now this is a multiple inequality. I need to solve both these inequalities and find the common interval, right? Common solution. So x square plus 6 by 5x should be greater than or equal to minus 1 and x square plus 6 by 5x should be less than or equal to 1. So let us take the first inequality. X square plus 6 by 5x should be greater than or equal to minus 1. So now how do we solve this? We bring this minus 1 onto this side. We don't cross multiply. So x square plus 6 by 5x plus 1 greater than or equal to 0. If I take LCM, x square plus 5x plus 6 by 5x greater than or equal to 0. This became a rational inequality. If I'll try to factorize the numerator, so you get x plus 2 into x plus 3 by 5x is greater than or equal to 0. Now this is a rational inequality. You can solve this using wavy curve method. So let me draw the wavy curve for this. So what are the critical points for this? All the leading coefficients are already positive. The critical points are minus 3, minus 2 and 0. And 0 is the pole of this rational function. And if you draw the wavy curve, all the powers are 1. So you have a sign changes at each 0 and pole. So you got the wavy curve, minus plus minus plus. I want my expression to be positive. That is this interval and this interval. So x belongs to closed minus 3 to minus 2 because you have equality also. Union open 0 comma infinity. 0 cannot be taken in the solution because 0 is the pole. So x square plus 6 by 5x is greater than or equal to minus 1 for this values of x. Next let us take the second case. X square plus 6 by 5x is less than or equal to 1. Again, I bring this 1 onto this side. X square plus 6 by 5x minus 1 less than or equal to 0. This implies x square minus 5x plus 6 by 5x less than or equal to 0. Again, I'll factorize the numerator. X minus 2 into x minus 3 by 5x less than or equal to 0. So again, I'll draw the wavy curve for this. This time, the critical points are 0, 2, and 3. And 0 is the pole again. So all the leading coefficients are positive. So I start from above the x-axis. So I draw the wavy curve. All the powers are odd. So sign change happens at each 0. So once you have this, plus, plus, minus, minus, I want the negative interval. So x belongs to minus infinity, comma, open 0, union, close to, comma, 3. So this is a solution for the second inequality. This is a solution for the first inequality. So let us find the common solution. So for the common solution, let me plot both of this on a single real number line. So if you take the real line, the first solution is minus 3 to minus 2. You have minus 3 here, minus 2, 0. So minus 3 to minus 2, union 0 to infinity. That's the first solution. So if you take the second solution, minus infinity to 0, minus infinity to 0, union 2, comma, 3. You have 2 here, you have 3 here. So you have 2, comma, 3. So now what is the common solution to these two? So as you can see, minus 3 to minus 2 is common for both of this, and 2 to 3 is also common. So the final solution for this equation is x belongs to closed minus 3 to minus 2. Closed minus 3 to minus 2 is there, is satisfying both these solutions. Union closed 2, comma, 3. So that's the solution to this inequation. So next type of functional inequations are exponential and logarithmic inequalities. So these two inequalities are slightly different from modulus inequalities because modulus function is a piecewise defined function. But exponential and logarithmic functions are not piecewise functions. They are uniformly defined functions. Now, in solving exponential and logarithmic inequalities, we use the concept of increasing and decreasing functions. This is the concept of increasing and decreasing functions. Now, what is the concept of inequalities related to increasing and decreasing functions? So, x1 is greater than x2 implies f of x1 greater than f of x2 if f of x is increasing function. So x1 greater than x2 implies f of x1 is greater than f of x2 if f of x is increasing, and x1 greater than x2 implies f of x1 is less than f of x2 if f of x is decreasing function. So these two statements are very important in solving functional inequalities. So if there are two numbers related by a particular inequality, after applying the function, the inequality remains same if the applied function is an increasing function. The inequality reverses if the applied function is a decreasing function. And this statement works both ways. That is, if f of x1 is greater than f of x2, then x1 will be greater than x2 if f is an increasing function. That is, an increasing function can be removed and the arguments follow the same inequality. If a decreasing function is removed, the arguments follow the reverse inequality. So this is the topic, this is the concept of increasing decreasing function inequalities. Now, to analyze exponential and logarithmic inequalities, we need to understand the increasing decreasing nature of these functions. So we know that exponential function is y is equal to a power x. So what is the nature of y is equal to a power x? Y is equal to a power x graph looks something like this. If a is greater than 1. If a is greater than 1, that is, if the base is greater than 1, then the function is an increasing function. And the graph looks something like this. If a is in between 0 and 1. If a is a fraction, then exponential function is a decreasing function. So you need to remember this. We'll see how to use this concept when we do problems. Next, similarly, logarithmic function. The graph looks something like this. If the function is y is equal to log x to the base a, so this graph looks like this if base is greater than 1. If base is greater than 1. That is, if the base is greater than 1, the logarithmic function is increasing. Similarly, the graph looks something like this. Graph looks something like this. Graph looks something like this if the base is in between 0 and 1. If the base is in between 0 and 1. So if the base is in between 0 and 1, logarithmic function is a decreasing function. So if you remember these two results, it is very easy to solve exponential and logarithmic inequalities. Now let us apply our concept in solving problems. Now let us look at these 4 very basic questions to understand the concept that we have learned. So let us say that we need to solve log x to the base 2 greater than 0. So how do we solve this? So let me do it in 2 different ways. One is the long way, that is complete way. The other is a shortcut. So log x to the base 2 is greater than 0 can be written as log 1 to the base 2, right? Because we know that log 1 to any base is equal to 0. So now log something to the base 2, log to the base 2 is a function for me. Log to the base 2 is a function. The arguments are x and 1. Log x to the base 2 is greater than log 1 to the base 2. Now if you remove this function, what is the sign that arguments follow? That depends on whether you are removing an increasing function or a decreasing function. Log to the base 2, because this base is greater than 1, it is an increasing function. So I am removing an increasing function. So x is greater than 1 is the answer. X is greater than 1. Now if you go to the next question, log x plus 5 to the base 4 is less than 1. So log x plus 5 to the base 4 is less than 1 can be written as log 4 to the base 4. So now if you want to go to x, let us remove this function. Log to the base 4, what is the nature of this function? It's an increasing function. So I can remove this. So the arguments follow the same sign because I'm removing an increasing function. This implies x is less than minus 1. X is less than minus 1. So whatever I'm doing, these are the values of x for inequality to be valid. So if you want the complete answer, you also have to make sure that the log function is defined. That comes under the topic of functions. So what are the values of x for which log is defined? For log to be defined, x has to be greater than 0. And for this inequality to be valid, x has to be greater than 1. So the effective solution is x is greater than 1. Similarly here, log x plus 5 to the base 4 is less than 1. For this inequality to be valid, x should be less than minus 1. But for this logarithm to be defined, x plus 5 has to be greater than 0. X has to be greater than minus 5. So both these inequalities have to be satisfied. That's the effective answer. That is, x lies between minus 5 and minus 1 is the effective answer for this inequality. Now if you go to the third one, log x plus 3 to the base 0.2 is greater than or equal to 2 times log 0.2 to the base 0.2. Log 0.2 to the base 0.2 is nothing but 1. Now according to the properties of logarithm, this 2 goes onto the power, right? So it's greater than or equal to log 0.04 to the base 0.2. Now, as you have to go to the arguments, you need to remove this function log to the base 0.2. And we have seen that if the base is in between 0 and 1, this is a decreasing function. So this function is a decreasing function. If you remove this function, so x plus 3 will be less than or equal to 0.04. The sign of inequality reverses. This implies x is less than or equal to minus 2.96. So this is the solution for this inequation. Further, you have to take x plus 3 greater than 0 also. So if x plus 3 greater than 0, x is greater than minus 3 is also should be valid. So x is greater than minus 3 and less than minus 2.96. It has to lie somewhere in between these two. That's the answer to this inequality. So before going to the fourth question, so let us try to solve this. Let us try to get these solutions using the shortcut method. So each time you don't need to do complete solution. So if you want to get the right answers, what you can do is, so log x to the base 2 is greater than 0. So log to the base 2 is an increasing function. So when you convert this into exponential form, the inequation does not change. So x is greater than 2 power 0. That means x is greater than 1 is the answer. So that's the direct answer for this inequation. So x is greater than 2 power 0. Because this base is greater than 1, the sign of inequality does not change. And here, the base is 4, hence the base is 4, hence is an increasing function. If you convert this into exponential form, the inequation does not change. So x plus 5 is less than 4 power 1 is 4. This implies x is less than minus 1. So this is the solution for the inequation. For the definition of this function, you have to separately test the condition. So x plus 5 has to be greater than 0 also. This implies x has to be greater than minus 5. So these two have to be satisfied. So if you go for the third function, so here the base 0.2 is less than 1. That is in between 0 and 1. So x plus 3, when you convert this into exponential form, the sign reverses. So less than or equal to 0.2 whole square is less than or equal to 0.04. So x is less than or equal to minus 2.96. So this is for this inequality to be valid. But for this log to be defined, x plus 3 has to be greater than 0. X has to be greater than minus 3. So x has to be greater than minus 3 and less than minus 2.96. So x has to lie in between these two values. So now let us go to the fourth question. So now if you look at this question is slightly different because the variable is not in the argument. The variable is in the base. So log 0.5 to the base x is greater than 2. So I'll solve this in two different cases. Case 1. If x is greater than 1. If x is greater than 1, I can directly convert this into exponential form. That is, x square is less than 1 by 2. X square is less than 0.5 is 1 by 2. So x square less than 1 by 2 implies x is in between minus 1 by root 2 to plus 1 by root 2. So if x is greater than 1, then x has to satisfy this interval. And so let us assume x is less than 1. That's the second. If x is less than 1, if I convert this into exponential form, the sign of inequality reverses. That is, x square is greater than 1 by 2. This implies x is either greater than 1 by root 2 or x is less than minus 1 by root 2. So these are the two cases. So in the first case, there is no solution, as you can see, because I have solved the first inequation in the case when x is greater than 1. But I got the roots as minus 1 by root 2 to plus 1 by root 2. So my x has to lie between this. There is no common interval. That means there is no solution here. And if x is less than 1, if x is less than 1, I am solving it in x less than 1. So the condition that I got is x is greater than 1 by root 2 and x is less than minus 1 by root 2. Less than minus 1 by root 2. So the effective solution can be x belongs to 1 by root 2 comma 1, right? 1 by root 2 to 1 union minus infinity to minus 1 by root 2. But this is not valid because for this logarithm to be defined, the base has to be positive. So this solution is not valid. So only this solution is valid. And 1 has to be open because this x base cannot be equal to 1 from the definition of logarithms. So the final solution for this inequation is x is in between 1 by root 2 to 1. So to check whether this is a closed interval or open interval, so you have an open interval here also because there is no equality. So open 1 by root 2 to 1 is the answer. So now if you take a look at exponential inequalities, so we solve it something like this. So if 2 power x is greater than 4, so I write it as 2 power x is greater than 4 can be written as 2 square. Now 2 power, here also you have 2 power. So 2 power something is an increasing function because an exponential function is increasing if the base is greater than 1. So 2 power x is greater than 2 square. 2 power is an increasing function. So if you remove this, the sign of the arguments does not change because we are removing a increasing function. So if you go to this, so 1 by 2 power x is less than, I can write 1 as 1 by 2 power 0. So if you remove this 1 by 2 power, 1 by 2 power something is a decreasing function. Hence, the sign of the arguments reverses. Or you can also do it like this. This is 1 by 2 can be written as 2 power minus 1. So 2 power minus x is less than 1. So 2 power minus x is less than 2 power 0. Now if you are removing 2 power, if you are removing 2 power something, so 2 power is an increasing function. So the arguments follow the same relation. Now this is minus x less than 0. This becomes a linear inequality. If I uniformly multiply both sides with minus, now the sign of inequality reverses. So finally you got the same answer. Now if you have this is a combined inequality, exponential and modulus. So first let me solve the exponential part. So e power mod x is less than or equal to e power 0. And e power is an increasing function. So the arguments have to follow the same inequality. Mod x is less than or equal to 0. Mod x can never be less than 0. So mod x has to be equal to 0. That means x is equal to 0. That's the solution. Now if you go for the fourth one, 10 power log x to the base e is greater than 100. So 10 power log x to the base e is greater than or equal to 10 square. So 10 power is an increasing function. So the arguments also follow the same inequality. Now log x to the base e is greater than or equal to 2. Again, e log to the base e is an increasing function. So if you convert this into exponential form, x is greater than or equal to e square is the answer to this question. So now that you have understood logarithmic and exponential inequalities, so let us go to the next inequality, which is called reciprocal inequality. So now there are three results in this topic. If a and b are two positive numbers, if 0 less than a less than b, if a and b are two positive numbers and a is less than b, then 1 by a will be greater than 1 by b. And if a and b are both negative numbers and a is less than b, then 1 by a will be greater than 1 by b. That is, the sign of the inequality reverses when you do reciprocal. That is, if this will be valid if either both are positive numbers or both are negative numbers. So this can be observed from the graph of y is equal to 1 by x, because you have a reciprocal function. So y is equal to 1 by x. If you take this reciprocal function, the graph of this is a decreasing function. So as you can see, as you move right on this graph, the graph is going down. Here also, as you move right, the graph is going down. That means this function is a decreasing function. So if you apply this function to some arguments, the sign of the inequality reverses. If a is less than b, 1 by a will be greater than 1 by b. And if a is less than b, if both are negative, then also, if both the numbers are negative, then also 1 by a will be greater than 1 by b. That is, the sign reverses. But you should understand, this is not a decreasing function throughout the interval. There is a jump here. There is a jump here. That is, if at this neighborhood of 0, if you go to the negative neighborhood of 0, the functional value is minus infinity. If you go close to 0 plus, the functional value is plus infinity. So as you jump from the negative side of 0 to positive side of 0, the function suddenly takes an infinity jump upwards. So if one of the value is positive, if a is negative and b is positive, if a is negative and b is positive, obviously a is less than b. Even after doing the reciprocal, a is a negative number, b is a positive number. So if you do the reciprocal, 1 by a will even now be a negative number and 1 by b will be a positive number. So 1 by a will be still less than 1 by b. So when you are doing reciprocal, make sure that you see the signs of the numbers that you are reciprocating. So if the signs of both the numbers are positive or both the numbers are negative, then reciprocal changes the sign. If one of them is positive, the other is negative, then the sign of the inequality does not change on reciprocating. For example, if 2 is less than 3, if 2 is less than 3, you know this. This implies 1 by 2 will be greater than 1 by 3. Right? And minus 3 is less than minus 2, but minus 1 by 3 is greater than minus 1 by 2. And minus 3 is less than 2. Now you have one negative number and another positive number. Now if you reciprocate this side will still be negative, this side will be positive. Hence, the sign of inequality does not change. So now let us try to apply this in some sample questions. So let us look at these two questions. So the first question is 1 by mod of x plus 2 is greater than 1 by mod of x plus 3. So how do we solve this inequality? So first, this is of the form 1 by something is greater than 1 by something. So as you can very clearly see, mod of something and mod of something, both these are positive. Both these numbers are positive. So 1 by this and 1 by this are positive numbers. So if you reciprocate these two, the sign of the inequality changes. So this becomes mod of x plus 2 is less than mod of x plus 3. So once you have applied the reciprocal inequality, now this has become a modulus inequality. And this is of the form mod of something is less than mod of something. So we have already learned in the topic of modulus inequality that this is exactly same as x plus 2 whole square is less than x plus 3 whole square. Mod x is less than mod y implies x square is less than y square. So this implies x square plus 4x plus 4 is less than x square plus 6x plus 9. So x square and x square gets cancelled. So this implies now this has become a linear inequality. So this 6x, if 4x goes onto that side, becomes 2x is greater than 4 minus 9 is minus 5. And this implies x is greater than minus 5 by 2 is the answer to this question. So I hope you understand the steps. So you cannot expect that. So mostly the questions will not be asked only using reciprocal inequality. This will be a sub-step in a big question. Now if you go to this question, this is also a very straightforward question. So 1 by x square is less than 1 by x plus 1 whole square. So here x square is positive and x plus 1 whole square is also positive. So both these numbers are positive, so I can reciprocate this. So x square and x plus 1 whole square So if this is less than, once you reciprocate this, this will become greater than. So this implies x square is greater than x square plus 2x plus 1. So x square and x square is getting cancelled. This implies 2x plus 1 is less than 0. This implies 2x is less than minus 1. So x is less than minus 1 by 2. So this is the answer to this inequation. So in this way, we can use reciprocal inequalities. So what you need to understand is the theory that we have learned. If both the numbers are positive or both the numbers are negative, if you reciprocate, the sign of inequality changes. If one number is positive and the other number is negative, the sign of inequality does not change when you apply reciprocation. So now, let us look at the next type of inequality called periodic inequality. So let us revise what periodic function is. So before going into periodic inequalities, you need to know what periodic functions are and certain properties of periodic functions. So a periodic function is a function which repeats after certain interval. That is, f of x plus some t is again equal to f of x. So after certain interval t, the function has to repeat itself. Then such functions are called periodic functions. For example, sin x is a periodic function with period 2 pi. Similarly, fractional part of x is a periodic function with period 1. So you would have learned this in the topic of periodic functions, the topic of functions. And what is the most important property that you need to remember about periodic functions, about periodicity of different functions? If f of x has a period of t, if a basic function f of x has a period of t, f of ax, if you substitute x with ax, it has a period of t by mod a. This is the most important property that you need to remember for periodic functions. For example, sin x has a period of 2 pi. So what is the period of sin 2x? Here x is being multiplied by 2. So the period becomes 2 pi by 2. That is pi. Similarly, fractional part of minus 2x. So what is the period of fractional part of x? The period is 1. So what is the period of fractional part of minus 2x? It is 1 by mod of minus 2 is 1 by 2. So that's the period. So now how do we solve periodic inequalities? That is, the inequalities involving periodic functions. Periodic inequalities are nothing but inequalities involving periodic functions. So how do we solve this? So the steps that we follow in solving periodic inequalities are, the first step is solve the inequation in any one period. So take the function, take any particular period and solve the inequality in that period. And let the solution be a to b. If this is the solution of the inequality in one period, the general solution will be equal to n times t plus a to n times t plus b. That will be the general solution. So these are the two steps that you need to remember while solving periodic inequalities. So now let us apply this two statements for some functions in specific examples. So let us take these two examples. Sin x is greater than or equal to half. So you need to solve this inequality. So what is the solution for this? So to solve this inequality, first I'll take one basic cycle of sin x. We know that the period of sin x is 2 pi. So let us take one basic cycle of sin x from 0 to 2 pi. So you can take any of the cycle. It's not that you have to take only 0 to 2 pi. If you want, you can take from minus pi to pi also. But you need to take one complete cycle. So for convenience, let me take 0 to 2 pi. So within this cycle, let us see where sin x is greater than or equal to half. So half is, we know that sin x goes from minus 1 to 1. So this is 1. So sin x will be half. Sin x will be exactly equal to half at two numbers. X is equal to pi by 6 and x is equal to 5 pi by 6. We know this from trigonometry. Sin 30 degrees is half. Sin 150 degrees is also equal to half. So if you carefully observe this graph, the graph of sin x lies above half, above y is equal to half, between pi by 6 and 5 pi by 6. So sin x will be greater than or equal to half, then x belongs to closed pi by 6 to 5 pi by 6, right? Because between pi by 6 and pi by 6, 5 pi by 6, the value of sin x is greater than or equal to half. So I am using closed interval because you have equality also. Now this is the solution in one cycle. So now what is the general solution for x? This is nothing but, what is the period of sin x? 2 pi. So n times 2 pi, that is 2n pi plus pi by 6 to 2n pi plus 5 pi by 6, where n belongs to integers. So this will be the general solution to this inequation. So this is because, so you get this interval in the first cycle. So similarly, if you extend this to the next cycle, in the next cycle also you get some interval. In the next cycle also you get some interval. In the previous cycle also you get some interval. And this interval will be uniformly placed at an interval of 2 pi. So when you add 2n pi, so for different values of n, you get different parts of this solution. So if n is equal to 0, you get pi by 6 to 5 pi by 6, that is this part. If n is equal to 1, you get 2 pi plus pi by 6 to 2 pi plus 5 pi by 6. That is the solution in the next interval. If you put n is equal to 2, you get the solution in the next cycle. If you put n is equal to minus 1, you get the solution in the previous cycle, and so on. Now, let's go to the next question. Fractional part of x is less than half. So here also we know that fractional part is a periodic function whose period is 0 to 1. Whose period is 1. So let us try to solve this inequality in one cycle. That is from 0 to 1. So if you take the function from 0 to 1, so you can very clearly see if fractional part of x is equal to half. So fractional part of x is equal to half when x is equal to half. And fractional part of x is less than half when x is in between 0 to half, right? So fractional part of x is less than half implies x belongs to closed 0 to open half, because you don't have an equality here. So x belongs to closed 0 to open half. So what is the general solution of x? So the general solution for x is, so what is the period of this? 1. So n times period, that is n times 1 plus 0 to n times 1 plus half. That is closed interval n to n plus half, where n is a integer. So n belongs to integers is the solution for this inequation. So I hope the things are clear. Thank you.